to Srivatsan Astro Kit, and today we will be talking about asteroids. I'll be explaining where they are found and the different types of them. Part 1. Asteroids. An asteroid is a minor planet, smaller than a meteoroid and not a planet or a comet, that orbit in the inner solar system, with a couple of exceptions that we'll talk about later. No two asteroids will look the exact same, as they vary significantly from little rubble piles to monsters like Ceres. Out of the about 1 to 2 million known asteroids in the solar system, most are between Mars and Jupiter in an area known as the asteroid belt. And here's a fun fact. All of the asteroids in the asteroid belt combined only equal to 3% of the Earth's moon's mass. And now we're going to move on to part 2, naming. Asteroids only have one way of being named. As of now, newly discovered asteroids get a provisional designation, the year of discovery, for example 2002, and a code showing the half month of its discovery and the sequence inside the half month as a number, for example AT4. When an asteroid's orbit is confirmed, they give it a number, for example 433, and sometimes gives it a provisional name, like Eros. And now part 3, formation and distribution. Most asteroids are the broken remains of planetesimals, bodies inside the sun's solar nebula that didn't get big enough to become full-on planets. Some proof of this is in Ceres and Vesta, which grew large enough to have their interiors differentiate, meaning they have a core, mantle, and crust, just like Earth. The asteroid belt is a massive belt of asteroids, containing about 1 to 3 to 1.9 million of them, larger than 1 kilometer. The leading theory are these asteroids are the remnants of a protoplanetary disk, as their formation into planets was prevented by Jupiter's gravity. Contrary to popular belief, the asteroid belt is almost completely empty. It would be impossible to hit an asteroid without performing the needed calculations and aiming for it, unlike in the cartoons, where flying through an asteroid belt is shown to be a precarious situation at its best. One of the exceptions here that we talked about in the part 1 is called Jupiter Trojans. They lie within Jupiter's orbit and Lagrange points, and more than 7,000 Jupiter Trojans are currently cataloged. There are also different planet Trojans, like Earth Trojans, Mars Trojans, or Uranus Trojans. However, it isn't known if Mars's moons, Phobos and Deimos, are captured asteroids by Mars or not. There are also near-Earth asteroids, which are the most hazardous type of asteroid and are located inside the asteroid belt instead of outside like the Trojans. There are different ways to classify NEAs, or near-Earth asteroids. The Atira type of asteroid has an orbit fully within Earth's orbit. Atens are mostly within Earth's orbit, but can cross it. The Apollos are mostly outside Earth's orbit, and Amors are strictly outside Earth's orbit. Okay. And now we're moving on to part 4, threats. There's becoming more and more interest in identifying asteroids that could cross Earth and that could collide with Earth. With the amount of classified asteroids becoming larger and larger, eventually two more things took the hypothesis of asteroids crashing into Earth to its breaking point. The Alvarez hypothesis that an asteroid wiped out the dinosaurs, and Shoemaker-Levy 9 crashing into Jupiter. Due to this, there have been many attempts to find a way for planetary defense, and the most successful one was the Double Asteroid Redirection Test, or DART. DART in 2022 showed that crashing into asteroids is viable, as it intentionally crashed into Dimorphos, a moon of the asteroid Didymos, slowing its rotation period by about 33 minutes. And now that concludes my video on asteroids, and goodbye and see you next time.